Good afternoon. Welcome to the session of grade 11. In this lesson, we are going to focus on functions and more specifically the straight line and the parabola. Now, the general equation of the parabola is given by the formula y is equal to ax squared plus bx plus c. If you can complete the square, you can also write it in the form y is equal to a x minus p all to be squared plus q. Now, if there is no b value, the parabola can be in the form y equal to ax squared plus c. If there's no b or c value, then y is equal to ax squared. If there's no c value, then y is equal to ax squared plus bx. Now, if there's no b value, we usually use the table method to sketch the graph. Now remember this a value here, if a is positive, if a is greater than 0, the parabola has got its arms up. And if a is less than 0, the parabola has arms down. This will give you a minimum value, and this kind of parabola will give you a maximum value. Right, now we're going to sketch the graphs of the following parabolas. Y is equal to x squared. We said if there's no b value, we're going to use the table method. Then x will take on the values, any values. We usually give it negative 0, 1, and 1, negative 1, 0, and 1, and we get the corresponding y value by substituting the x values into the equation of the parabola. If x is negative 1 squared is 1, so y is 1. If x is 0, 0 squared is 0. And if x is 1, 1 squared, the y value is 1. Now to plot the points, it is negative 1, 1, it is 0, 0, and it is 1, 1. And then we draw a straight line through those points. Now you can see in this case that this has a minimum value. And if the coordinates of this point here is 0, 0, so the minimum value is the y value of the turning point. So the minimum value is y equal to 0. Now if we look at the graph, what is the domain here? All x values will hit the graph. So the domain is x an element of real. What is your range? All y values greater than 0 will hit the graph. So in this case, y here is greater or equal to 0, y an element of real, or y an element of positive real numbers. Or y is an element of 0 to infinity. Square brackets are 0 because 0 is included, and always round brackets on infinity and negative infinity. Now we said the minimum value is your y coordinate to the turning point, so y equal to 0 is your minimum value. Your axis of symmetry is this x value here, which is x equal to 0, which is the y-axis. And we said the turning point was 0, 0. Right, in this case here, if we have to sketch the graph of y equal to negative 2x squared plus 1, in this case we've got an a and a c value, there's no b value. So we make use of the table method to sketch the graph. Then x can take on any values. In this case we're going to give it the value of negative 1, 0, and 1. If we put negative 1 in place of x, negative 1 squared is 1 times negative 2 is negative 2 plus 1 will give you negative 1, y equal to negative 1. If you put x equal to 0 into there, 0 squared is 0 times negative 2 is 0 plus 1, the y value is 1. And 1 squared is 1 times negative 2 is negative 2 plus 1 is negative 1, the y value is negative 1. Now if I plot the points, it's negative 1, it's 0 and 1, and it is 1 and negative 1. And because the a value is negative, the parabola arms is down. The domain here, all x values will hit the graph. So the domain is x an element of real. In this case, the range, all y values less than 1, less or equal to 1 will hit the graph. So y is less or equal to 1, y an element of real. Or you can use the notation y is an element of negative infinity to 1. Square brackets on 1 because 1 is included, and infinity and negative infinity always take round brackets. Now, the minimum value is your y coordinate of the turning point, so y equal to 1 is your minimum value. Remember we said if the graph looks like this, it's a minimum, and if the graph looks like that, it's a maximum value. And the minimum and the maximum value is always the y-coordinate of the turning point. The axis of symmetry in this case is x equal to 0, or the y-axis, and we said the turning point was 0, 1. Right, now in the next section of work, we're going to show how to write y equal to ax squared plus bx plus c in the form y is equal to ax minus p ought to be squared plus q. So we're going to use the steps of completing the square. Your first step is to make the coefficient of x squared 1. The next step is to keep the first two terms, and then you add half the coefficient of x ought to be squared and subtract that same number. Then we can factorize the perfect square trinomial, and then we multiply in by the coefficient of x squared. So those are the steps to complete the square. You can see we are first running through the theory before we do the past paper questions. Now in this case, we need to write y equal to negative 2x squared plus 4x negative 6 in that form. So we're going to complete the square. The first step is to take out negative 2, because we've got to make the coefficient of x squared in the brackets 1. Now, negative 2 times x squared is negative 2x squared. Negative 2 times negative 2x is positive 4x. And negative 2 times positive 3 is negative 6. So we changed the expression within the brackets because we took out the coefficient of x squared, which was negative 2. Then the next step is to keep the first two terms, and we add the coefficient of x is negative 2, so half of negative 2 is negative 2 over 2, ought to be squared. If we added negative 1 squared, if we added 1, then we need to subtract the same number, which is negative 1, and the plus 3 remains. Now we're going to complete the square here. So it becomes x squared negative 2x plus 1, and this here becomes negative 1 plus 3. Now we're going to find the perfect square trinomial. So the factors of x squared negative 2x plus 1 is x negative 1 ought to be squared, and negative 1 plus 3 is equal to positive 2. So in this case, now we multiply in by the a value. Negative 2 times x minus 1 squared is negative 2x minus 1 squared. Negative 2 times positive 2 gives you negative 4. So in this case, we can say the axis of symmetry is opposite sign of this. So the axis of symmetry is x equal to positive 1, and the turning point is the axis of symmetry, which is in this case 1, and the y-coordinate of the turning point is that value as is, negative 4. So your axis of symmetry is 1, your turning point is negative 4. So what do you know? Because the a value is negative, it's a maximum value, and the maximum value is the y-coordinate of the turning point. If the turning point is 1, negative 4, then y equal to negative 4 is your maximum value. Right, in this case here, we need to write the following equation in that form. Y equal to ax minus p to be squared plus q. Now your first step is to make the coefficient of x squared inside the brackets 1. So we take out negative, and this becomes x squared negative 5x plus 3. Again, we're going to make the coefficient of x squared 1 inside the bracket, so we took out the coefficient, which is negative 1. Now, negative times x squared is negative x squared. Negative times negative 5x is plus 5x, and negative times positive 3 is negative 3. So now we say y is equal to, in this case, we keep the first two terms, x squared negative 5x, and we add half the coefficient of x. Now the coefficient of x is negative 5. Half of it is negative 5 over 2 to be squared. If we added 25 over 4, we subtract 25 over 4, and that plus 3 remains. So now y becomes negative. This here becomes x squared negative 5x plus 25 over 4, right? And then we're going to say plus. The LCD of 4 and 1 is 4. So we say 4 goes into 4, 1 times negative 25 is negative 25. 1 goes into 4, 4 plus 3 is 12. So 1 goes into 4, 4 times 3 is positive 12. So this here, in this case, becomes, right, this here becomes y is equal to negative, bracket. In this case becomes x squared, same sign, both negative, or x negative 5 over 2 to be squared, and then you're going to add. The LCD here is equal to 4, and we said in this case 12 minus 25 will give you 13, so it becomes negative 13, and now we can multiply in by the negative. So y is equal to negative bracket x minus 5 over 2 to be squared negative, and a negative becomes plus 13 over 4. Right, and then 13 over 4 is equal to 3 1/4. In the next sum, we got to sketch the following graph. We're going to sketch the graph of y is equal to negative 2 brackets x minus 3 ought to be squared plus 8. Now your first step is a is negative, so we know it's going to be hands down. Now your axis of symmetry, we can say x is equal to the opposite sign of this, which is 3. Your turning point in this case is the opposite sign of this, and that value as is, so it is 3, 8 is your turning point. And your x-intercept, we need to put y equal to 0. So negative 2 brackets x minus 3 to be squared plus 8 is equal to 0. So negative 2 bracket x minus 3 to be squared is equal to negative 8. So x minus 3 to be squared is equal to, divide negative 8 by negative 2, we get 4. So x minus 3 is equal to plus minus square root of 4. So x minus 3 is equal to 2, or x minus 3 is equal to negative 2. So x is equal to 1, or x is equal to 5. So x-intercepts is 1 and 5. Your turning point here is x equal to 3, y equal to 8. 3, 8 is your turning point, and then you say your y-intercept. We're going to put x equal to 0, so y is equal to, if x is 0, then we're going to say 0 minus 3 is negative 3 squared is 9. 9 times negative 2 is equal to negative 18, plus 8 is equal to negative 10. So your y-intercept here is negative 10. And then if I join the points, this will be your parabola. X-intercept, if I join the points, remember your x-intercept is 1 and 5, your turning point is 3, 8, your y-intercept is negative 10, and that would be the shape of the parabola. Right, in the case, the graph of y equal to ax squared plus bx plus c is a parabola, and b is not equal to 0. So if b is not, remember, if b is equal to 0, we use the table method, but b is not equal to 0, then we will sketch the parabola using the following steps. We'll find the y-intercept by putting x equal to 0, the x-intercept by putting y equal to 0. We're going to use the formula for the axis of symmetry, which is given by x is equal to minus b over 2a. Now b is the coefficient of x, and a is the coefficient of x squared, and then we will find the turning point, and then we're going to sketch the graph. So in this case here, we're going to find your x and your y-intercept. So we're going to say x-intercept, we need to put y equal to 0. So 2x squared negative 3x negative 2 is equal to 0. Factors of 2x squared is 2x multiplied by x. Factors of 2 is 2 and 1. This here is negative and positive equal to 0. So now x here, 2x plus 1 is equal to 0, or x minus 2 is equal to 0, so x is equal to 2, or x 2x is equal to negative 1, x is equal to negative a half. That's your x-intercept. Now your y-intercept, we're going to put x equal to 0. So that is 0 squared is 0 times 2 is 0, minus 3 times 0 is 0, negative 2. So y equal to negative 2 is your y-intercept. Now your axis of symmetry, so we're going to say axis of symmetry. We're going to use the formula x is equal to negative b over 2a, but the b value in this case is equal to negative 3, so it is negative 3 over 2 times 2, which is equal to 3 over 4. Right, once again, the b value is negative 3, the a value is 2, so I'll substitute b equal to negative 3, the a value 2, and I'll simplify. Now to find the turning point, we're going to say that y is equal to 2 times, now x now is equal to 3/4, 3 over 4 squared minus 3 times 3 over 4 minus 2, and that is 9 over 16, and then 2 goes into 16 8 times, so it's 9 over 8 minus 9 over 4 minus 2 over 1. So your LCD here is 8. So it's 9 minus 18 minus 16. So this here becomes the 9 minus 18 is negative 9, negative 25 over 8. Right, again, what I'm going to do is I'll put x equal to 3/4 into the equation of the parabola. So it's 2x squared, so 3 over 4 squared minus 3x, negative 3 times 3/4 minus 2. This is 9 over 16, and 2 goes in 16 8 times, so it's 9 over 8. This becomes negative 9 over 4 minus 2 over 1. Your LCD is 8. So it becomes 9. 4 goes into 8 twice, negative 18, and 1 goes to 8. 8 times negative 2 is negative 16, is negative 25 over 8. And that is equal to negative 3, which is 24, and 1 over 8. So in this case, to sketch the graph, we're going to say your x-intercept is equal to negative a half and 2. Your axis of symmetry is 3/4 and negative 3 and 1 over 8. So it is 3/4 and negative 3 and 1 over 8. And your y-intercept here is negative 2. So, and because the a value here is positive, the arms are up. So your y-intercept is negative 2, your x-intercept is negative half and 2, and your turning point is 3/4 and negative 3, 1 over 8. Right. Now, another important concept to master is to find the equation of a parabola. If we are given two x-intercepts and a point, we're going to make use of the formula y is equal to a, x minus x1, and x minus x2. Now, to do an example of that, so if I use my x-intercepts, now x1 is negative 3, so x minus 3 is x plus 3, and x2 is your other x-intercept, which is 4, so it's x minus 4. Then I substitute the point it passes through, which is 1, negative 24. Y is negative 24, and x is 1. So yeah, you can say 1 plus 3 is 4, 1 negative 4 is negative 3, 4 times negative 3 is negative 12, times a is negative 12a, and you solve for a. Divide both sides by negative 12, so a is 2. Then you put the a value of 2 back into the equation with the two x-intercepts, and you can multiply out. So you can say y is equal to 2 brackets, x squared negative x negative 12, and so y is equal to 2x squared negative 2x negative 24. So that is what you need to do. If you are given two x-intercepts and a point, you're going to make, if you're given two x-intercepts and a point, you're going to make use of this equation. You first substitute your x-intercepts, then your point, and you solve for a. Once you've got a, you put it back into the equation with the x-intercepts, and you multiply out. The other important concept to know is that How do you find the equation? If you are given a turning point and a point, if you're given a turning point and a point, you will make use of this equation. Y is equal to a, x minus p to be squared plus q. Now your first step is to substitute your turning point. That's your p and your q value. So the p is equal to 2 and your q is equal to 3. And then I substitute the point it passes through. In this case, it passes through 1 and 2. So I'll substitute 1 and 2. X here is 1 and the y value here is 2. So 1 minus 2 is negative 1 squared is 1 times a is a plus 3. Take the 3 across. 2 minus 3 is negative 1. A is negative 1. Then you put the a equal to negative 1 back into the equation with the turning point, and then you can multiply that out. If they ask you to leave it in that form, you can leave it in that form. If they ask you to leave it in the form y is equal to ax squared plus bx plus c, then you multiply that out. Right, in this case, we need to find the equation. We need to find the following. We've got to find the equations in that form. Right, so we are given a turning point and a point. So we're going to make use of the equation y is equal to a, x minus p to be squared plus q. Your first step is to substitute your turning point, that is your p and your q value. So y is equal to a, x minus 1 is x plus 1 to be squared plus 5. And what you need to do now is you now need to substitute the point that it passes through, and it passes through 113. So you substitute x equal to 1, y equal to 13. 13 is equal to a, it's 1 plus 1 squared plus 5. 13 minus 5 is 8 is equal to 2 squared is 4a. So a is equal to 2. Right, so we substituted x equal to 1, y equal to 13. So 1 plus 1 is 2 squared is 4 times a is 4a. 13 minus 5 is 8, and you solve for a. Then you put a back into the equation with the turning point. So y is equal to 2 brackets x plus 1 to be squared plus 5. So you can leave it in that form. If they ask you to leave it in the form y is equal to ax squared plus bx plus c, then we need to multiply that out. So we can say y is equal to 2 brackets x squared plus 2x plus 1 plus 5. Y is equal to 2x squared plus 4x plus 2 plus 5. Y is equal to 2x squared plus 4x plus 7 is the equation. Right, if they ask you to find the equation of the parabola given two x-intercepts and a point, we're going to make use of the formula y is equal to a, x minus x1 and x minus x2, correct? So y is equal to a, that is x plus 4 and x minus 2. Then we're going to substitute in the point 3, negative 14. So in this case, y is negative 14. Negative 14 is equal to a. Your x value is 3. So it's 3 plus 4, and it is 3 minus 2. So this here is 1, and 7 is 7 times a is 7a. Negative 14 is equal to 7a. Divide both sides by 7, so a is equal to negative 2. Then you could put negative 2 back into the equation with the x-intercepts. So y is equal to negative 2 brackets x plus 4 multiplied by x minus 2. So y is equal to negative 2 brackets x squared plus 2x negative 8. Now you multiply in by negative 2. Y is equal to negative 2x squared plus, or that is negative 2 times that is negative 4x plus 16. So your final answer is y is equal to negative 2x squared, negative 4x plus 16. Right, in this case here, we are using a bit of translation, shifting the graph left and right and up and down. They say, what will the equation of y equal to... Right, let's start off with this equation first. What will the equation of y equal to x squared negative 2x negative 3 be when moved 2 units to the right and translated 3 units down? Now, the first step here is to take that negative 3 across, so I get y plus 3. Now I'm left with y plus 3 is equal to x squared negative 2x. Now, if it shifts 2 units to the right, then I was going to say x negative 2 ought to be squared. Wherever there's x, I put x negative 2. Wherever there's x, I'm going to put x negative 2. And if it goes 3 units down, I'm going to put minus 3. So if it moves left and right, I put those numbers by the x's. If it moves to the right, I put negative 2. If it moves to the left, I put plus 2. And 3 units down means negative 3. Now you can multiply that out. If that is negative 3, take the negative 3 across, becomes negative 3. And then becomes x negative 2 squared is x squared negative 4x plus 4. And this becomes negative 2x plus 4. That negative 3, negative 3. If you simplify, you're going to get x squared, negative 4x, and negative 2x, negative 6x. And 4 plus 4 is 8, minus 6 is plus 2. That's your equation. So remember, if it moves to the right, we're going to say x negative 2. If it moves to the left, we're going to say x plus 2. And up and down, we're just going to leave that constant there as positive if it goes up, negative if it goes down. Now, if the equation is given in this form, y is equal to negative 2 brackets x minus 1 to be squared plus 3, and it moves 3 units to the left. Now, in this case, and it's translated 2 units up. Now, what we're going to do there is, I'm going to say 3 units to the left. Wherever there's x, I'm going to put x plus 3. So x is replaced with x plus 3, and that's negative 1. That's plus 3, and if it moves 2 units up, I'm going to add 2 there. Now I'm going to multiply that out. So this here becomes x plus 2 to be squared. So it's negative 2 times x plus 2 to be squared, and 3 plus 2 is 5. You can leave it in that form, or if you multiply it out, then you can leave it in the form y is equal to ax squared plus bx plus c. Right. Before we do the past paper questions, we're just going to take a 5-minute break, and then we will continue with the section of work. Welcome back to the session on functions, grade 11. We have discussed the theory on the parabola. Now we'll discuss the theory of the straight line, and then we'll do past paper questions. Now the general equation of a straight line is given by the formula y is equal to mx plus c. Now m here is the gradient or slope, and c here is your y-intercept. Now if the gradient is positive, it's an increasing slope. If the gradient is negative, it's a decreasing slope. Now it's very important that if 2 lines are parallel, then the gradients of the 2 lines are equal. And if 2 lines are perpendicular, then we know that the product of the gradients of the 2 lines is equal to negative 1. For example, if line 1 as a gradient is equal to 3, then what is the gradient of line 2 if it's perpendicular? It is opposite sign and the inverse. If this is positive, then the gradient is negative. If it's 3 over 1, it's a third. Because 3 times negative a third will give you negative 1 if the 2 lines are perpendicular. Now, just a quick summary to sketch the straight line. If there's no c value, we're going to use the table method. In the same way, if there's no b value for the parabola, we use the table method. Now, x can take on any values. I'm going to use negative 1, 0, and 1. If I put negative 1 in there, 2 times negative 1 is negative 2, 2 times 0 is 0, 2 times 1 is 2. And then we can sketch it. So we're going to say negative 1 and negative 2, negative 1 and negative 2. It is 0, 0, and it is 1 and 2. X equal to 1, y equal to 2, and it is a straight line passing through those points. This here is 1, 2, 0, 0, which is the origin, and this here is -1, -2. And you can see the gradient is positive. It's positive 2, so it's an increasing slope. If we have to sketch the following graph, 2y plus 4x -6 equal to 0, I'm going to make y the subject of the formula. So we keep 2y here, we take 4x across, becomes -4x, we take -6 across, becomes +6. And if I divide both sides by -2, then y is equal to -2x plus 3. Now in this case, if we need to sketch a straight line, if there's m and c, I'm going to use the dual intercept method, which means the x-intercept, you put y equal to 0, and the y-intercept, you put x equal to 0. Now, if I put y equal to 0 in this equation, I get -2x plus 3 is equal to 0. -2x is equal to -3. So x is equal to -3 over -2, which is equal to 3 over 2. And if I find the y-intercept, I'm going to put x equal to 0. So y is equal to -2 times 0 plus 3. So y is equal to 3. So your y-intercept is 3. And your x-intercept is 1.5. So that's -1, that's 1, that's 2, that's 3, -1, -2. So in this, your x-intercept here is 1.5, which is there, which is 3 over 2. And we're going to draw a straight line through those 2 points with where your y-intercept is 3 and your x-intercept is 1.5. And you can see in this case the gradient is negative, so it's a decreasing slope. So the 2 important things to remember: to sketch a straight line graph, if it's got m and c, I use the dual intercept method, which means x-intercept put y equal to 0, y-intercept I put x equal to 0. And if, in this case, if it's m but no c, I'm going to make use of the table method. Right. Now with that theory, we can focus on the past paper questions. In this case, we can say the diagram below shows the graphs of fx equal to -x squared, -x plus 6. And gx is the straight line given by the formula mx plus c. The coordinates of A, which is the point of intersection of the parabola and the straight line, is -2, 4. Right, the first question is, I need to determine the x-intercepts of f. Now, to determine the x-intercepts of f, I'm going to put y equal to 0. Now remember, the graph of f is given by the formula fx is equal to -x squared, -x plus 6. That is the graph of f. So to find your x-intercept, we need to put y equal to 0. Right, if I put y equal to 0, we're going to get -x squared, -x plus 6 is equal to 0. So x squared plus x minus 6 is equal to 0. So now it becomes x plus 3 and x minus 2 is equal to 0. So x is equal to -3 or x is equal to 2. So in this case here, we've got x equal to -3 and this here is 2. So the coordinates of C is 2, 0 and the coordinates of B is -3, 0. So here we can write the coordinates of B is -3, 0 and the coordinates of C is 2, 0. Those are your x-intercepts. But in your next question, which is 6.2, remember fx is given by the formula -x squared, -3x plus 6, and we said the B's coordinates here is -3, 0, and that is equal to 2, 0. Let's say write down the equation of the axis of symmetry. We're going to find the equation of the axis of symmetry. So in 6.3, we're going to say axis of symmetry, x is equal to minus b over 2a. But your b value in this case is negative 1, so it's negative 1 over 2 times negative 1, it is negative a half. That's your axis of symmetry. I repeat, your a value is negative 1, your b is negative 1, and your c is 6. So if b is equal to negative 1 and a is equal to negative 1, I substitute into the formula and I simplify. Now, that is 6.2. Now, in 6.3, they want to find the range of f. So I need to find my turning point. So I know that fx is equal to negative x squared negative x plus 6. And the f of negative a half is equal to negative a half squared negative a half plus 6. So it's equal to negative times a quarter plus a half plus 6. So to find, in this case, we need to find the turning point. So your LCD here is 4. So the 4 goes into 4 once, times negative 1 is negative 1, plus 2 goes to 4, 2 times 1 is 2, 1 goes to 4, 4 times 6 is equal to 24, 26, 25 over 4, 25 over 4. Right, so your turning point in this case, your turning point is equal to negative a half and 25 over 4, which is in this case is 6 1/4. Or you can say it is negative a half and 6 1/4. That's your turning point. So your range here will be all the y values less than 6 1/4. Right. Your turning point here is negative a half and 6 1/4. So which y values will hit the graph? All y values less than 6 1/4. So your range here, you can say the range, y is less or equal to 6 1/4, y is an element of real, or you can say in this case that y is an element of negative infinity to 6 1/4 square brackets, because it includes negative infinity, takes round brackets. The next question, write down the equation of G. The next question, we're going to find the equation of G. Now we've got to this point here, the point A. Now the point A is given by negative 2, 4, negative 2 and 4. That's that point there. And we're going to find D. Now D in this case is your y-intercept. And your y-intercept, we need to put x equal to 0. Now if we use this formula here, and if x is 0, then y is equal to 6. So this point here is 0, 6. That's the point of D. So now we've got 2 points. Now we need to find the equation of the straight line. So we can say the gradient of AD is equal to change in y over change in x, and that is equal to 6 minus 4 over 0 minus 2, which is equal to 2 over 2, which is equal to 1. The gradient is 1. And we know the y-intercept is 6 because it cuts the y-axis at 6. So your C value is 6. So your equation is given as y is equal to x plus 6. That's the equation of the straight line passing through the 2 points A and D. The next question is write down the average gradient between the points A and D. Now we said A here is equal to -2 and 4, and D's coordinates here is 0, 6. Now the average gradient has got the same value as the equation of the straight line passing through the 2 points. So in this case we can say that the gradient of AD is equal to 1. That we did from 6.4. So the average gradient also is equal to 1. It's the same as the gradient of AD. The average gradient is the gradient on a curve, is the gradient of a straight line passing through the 2 points. So the gradient of the line AD is 1, so the average gradient between the same 2 points is also 1. Right, and then the last question. The last question in this case, they said, determine the equation of H if H is a reflection of F about the x-axis, and then it is translated 3 units to the right. It is then translated 3 units to the right. Okay, so, and we're going to leave your answer in that form. So, let's quickly have a look. Fx. We got Fx in this case, and we are busy with the last question, which is 6.6. Fx is equal to -x squared -x plus 6. Right, if it's reflected in the x-axis, then your y becomes 0. So y is equal to -x squared -x plus 6. If it's reflected in the x-axis, x remains the same, but the y changes in sign. Right, that's the first translation that's taken place, or reflection, in the x-axis. X remains the same, y changes in sign, and make y the subject of the formula. X squared plus x minus 6. Now, if this graph is also translated 3 units to the right, then we're going to use x minus 3. So wherever there's x, we put x minus 3. So here we can say hx is equal to x minus 3 to be squared, plus wherever there's x, you put x minus 3 and minus 6. And it is not only translated 3 units to the right. Okay, it's only translated 3 units to the right, so that's fine. So in this case, we're going to multiply out. So it's reflected in the x-axis, so the y changes in sign, x remains the same. And if it's translated 3 units to the right, wherever there's x, I put x negative 3, wherever there's x, x negative 3, to find the equation of hx. Multiply out, x squared negative 6x plus 9 plus x minus 3 minus 6, and that is equal to x squared. That's negative 6x plus x is negative 5x, and 9 and negative 9 cancels out. So hx is equal to that. But they don't want it in that form. They want it in the form y is equal to ax minus p to be squared plus q. So we're going to say hx, your first step is to make the coefficient of x squared 1. It is 1. So we keep the first 2 terms, then we add half the coefficient of x. The coefficient of x is negative 5. Half of negative 5 is negative 5 over 2 to be squared. If we add 25 over 4, we must subtract 25 over 4. And in this case, here we got to find the factors, same sign, both negative. So it's x squared negative 5x plus 25 over 4. Perfect square trinomial minus 25 over 4. So that is equal to x, same sign, both negative, negative 5 over 2 to be squared, negative 25 over 4. And negative 25 over 4 is also given as negative 6 and a quarter. So you can also write it as x negative 5 over 2 to be squared, negative 6 and a quarter. Right, the other way in which this could have been done, you could have first of all taken your fx equation, and then you could have rewritten it in the form y is equal to a x squared minus bx plus c. Now you could have taken that form fx equal to negative x squared negative x plus 6, and rewritten it in the form y is equal to ax minus b to b squared plus q, and then do the shifting of left and right and up, and then translation, etc. So that's fx. So what have we got here? So we make the coefficient of x squared 1, negative bracket x squared plus x negative 6. Right, then you keep the first two terms, keep x squared plus x, add half the coefficient of x, which is 1 half of 1 is 1, to be squared. If you added 1, you subtract a quarter minus 6. Right, so it becomes negative. This here becomes x, same sign, both positive, x plus a half to be squared, negative 6 and a quarter. Now you multiply in. So that becomes negative bracket x plus a half squared plus 6 and a quarter. So fx can be rewritten in that form because hx, the answer had to be written in that form. Then they said to us, now hx is a reflection in the x-axis. That means the x-coordinate remains the same, the y-coordinate changes in sign, so the y becomes negative, then you multiply it across, so it becomes positive. So it becomes x plus a half to be squared, and a negative times a positive is a negative, so it's negative 6 and a quarter. Right, just to explain that, fx is equal to that, but hx is a reflection in the x-axis. So the x remains the same, but the y-coordinate changes in sign, so it becomes negative y. Then you multiply it across by a negative. So negative y times a negative becomes plus y. And a negative becomes a plus, and a positive times a negative becomes a negative. Now in this case here, we're going to do the shifting. So it's shifted 3 units to the right. So wherever there's x, we're going to the right, we're going to put minus 3 to be squared, minus 6 and a quarter. So therefore it becomes x negative 5 over 2, which is 2.5 minus 6 over a quarter. So whether you did it this method or whether you did it this method here, you'll see both solutions are the same. Right, let's look at 6.7. In this case, they say write down the values of x for which fx is greater than 0. So now we know that this here is negative 3, 0, which we worked out. And we know that this here is 2, 0, and that we already determined in the previous questions. Now, where is fx greater than 0? Now, fx is greater than 0, yeah, it's positive, yeah, between those two values. So we can say, yeah, for x is greater than negative 3, but less than 2. Or you can say that x is an element of negative 3 and 2, round brackets. Any of those two notations are correct. Where is fx positive? The fx is a y value. It's positive there for the parabola between negative 3 and 2. And those values are not included. If it was an equal sign there, then we would put equal signs in your answer. We leave out equal signs if there's an asymptote involved or if it's a fraction and it makes the denominator 0. Now, in this case here, the last one, 6.8, before we do the last question, 6.8 says that the f of p is equal to the f of 3 is equal to 4. So it tells you that the y value here is 4. The y value is 4. So this value here is negative 2. And this value here we can determine by using the axis of symmetry. Now the axis of symmetry here, we already worked out this value, we already worked out the turning point. If we look at the previous questions, the previous questions would tell us what the axis of symmetry is. I'm just going to write it down in this case. It is negative a half and 6 and a quarter. So the axis of symmetry in this case is negative a half. So if it goes from negative a half to negative 2, what will this value here be? In this case, we can say this y value here, this here is negative 2. So from negative a half to negative 2, we moved 1.5 units. So from negative a half to 1, we've moved 1.5 units. So this p-value here is 1. Remember, the distance here is 1.5. So negative half plus the distance here of 1.5 will give you an x value of 1. So now we know this r value is equal to negative 2, and this p value here is equal to 1. How did we get that? The f of p is equal to the f of 3 is equal to 4. The y coordinate here is 4, so I use symmetry to get the value of r and p. Now they want p minus r if r is less than 0. r is less than 0, so p minus r is equal to 1 minus 2, and that is equal to 1 plus 2, which is equal to 3. So the value of p minus r is equal to 3 in this case. Again, I will explain that. They say the f of p is equal to the f of r is equal to 3. Now, it's equal to 4. Now, this y value here is 4. This x value here is negative 2. Because r is less than 0, r here is negative 2. Now, the distance here, from negative half to negative 2, the distance is 1.5. So, this distance here should be 1.5. So, negative a half plus 1.5 will give you x equal to 1. So, your p value is 1. Remember, this y value here is 4. The y value is 4. So, r minus p, or p minus r, is 1 minus 2, which gives you a value of 3. P minus r, p is 1, r is negative 2, so it gives you a value of 3. Right, let's look at question 5. This is the last question. They say the sketch represents the graphs of the functions defined by fx is equal to negative half x squared plus x plus 3 over 2, and gx is equal to mx plus c. Now they want the coordinates of a and d. So they're actually looking for, in this case, is your x-intercept. So here we can say your x-intercept, we need to put y equal to 0. So we're going to take the f graph, which is negative a half x squared plus x plus 3 over 2 is equal to 0. Right, I repeat. The f graph is given as negative x squared, negative a half x squared plus x plus 3 over 2, and the y-intercept is 0. Now we solve for x. The LCD is equal to 2. So 2 goes into 1 times negative x squared is negative x squared. 1 goes into 2, 2 times x is plus 2x. 2 goes into 1 times 3 is equal to 0. So it's x squared negative 2x negative 3 is equal to 0. So here we're going to say it is x minus 3 and x plus 1 is equal to 0, x is equal to 3, or x is equal to negative 1. Right. So in this case we can say d is 3 and this is negative 1. If they want the coordinates of a is negative 1, 0, and the coordinates of d is equal to 3, 0. Now, the next thing, they want c's coordinates, the turning point. So first of all, we're going to work out the axis of symmetry. Now, I know that fx is equal to negative a half x squared plus x plus 3 over 2, right? Now, the axis of symmetry, right, fx is equal to that, so the axis of symmetry, x is equal to minus b over 2a. Now the b value is 1, so it's negative 1 over 2 times negative a half, which is negative 1. So the axis of symmetry, x is equal to 1. Now, to get the y coordinate to the turning point, we're going to find the f of 1. So it's negative a half times 1 squared plus 1 plus 3 over 2. So this is negative a half plus 1.5 is 1 plus 1 is 2. That is equal to 2. So the coordinates of the turning point C is 1, 2. So C's value here is 1, 2. And we already worked out the values of A, it's negative 1, 0. And D here we worked out to be 3, 0. Now they want the values of M and C in the straight line equation. Right. So here we've already got D. Now we need B. B here is the y-intercept. Now how do I find the y-intercept? I'll put x equal to 0. 5.1.3 y-intercept. We need to put x equal to 0. So now we're going to say the f of 0 is equal to negative a half times 0 squared plus 0 plus 3 over 2. So y is equal to 3 over 2. So the coordinates of D is 0, 3 over 2. So we've got D and we've got to this point B, which is B here is 0, 3 over 2. B is 0 and 3 over 2. So we've got those 2 points. So now we can find the gradient. And your y-intercept here, C value, is 3 over 2. So let's have a look here. We can say the B value. We can say the B value is 0, 3 over 2. The D value is 3, 0. Now the gradient of BD is equal to changing y over changing x, and that is equal to 3 over 2 minus 0 over 0 minus 3, and that is equal to, right, we said it is 3 over 2 minus 0, and it is 0 minus 3 over 2, so it is 3 over 2 divided by negative 3 over 1, which is 3 over 2 times by negative 1 over 3. So the gradient is negative a half. And your C value is equal to 3 over 2. Now, what all they wanted to do is to find the values of M and C. So the M value here is negative a half, and your C value is equal to 3 over 2. Now, in this case here, they said find the coordinates of P where the length of KL is a maximum value. Right, let's quickly have a look at this. Now, let's quickly put in these values again. This is negative 1, 0. The D value here is 3, 0. This B value here is 0 and 3 over 2. And the coordinates of C here is 1, 2. Right. Now, first of all, we've got to find the P value for which KL is a maximum value, and KL runs parallel to the y-axis. So we've got to find the equation of KL. So the Parabolas equation, right, the Parabolas equation, which is f, is given by y is equal to negative a half x squared plus x plus 3 over 2. And g, which is the straight line, is given as y is equal to negative a half x plus 3 over 2. Now the next one is KL. So here we can say KL, y is equal to the top graph minus the bottom graph. Remember, to work out KL, it's the top graph, which is the parabola, minus the bottom graph, which is the straight line. So here we can say it is the parabola minus the straight line, which is equal to negative a half x squared plus x plus 3 over 2 plus a half x minus 3 over 2. Correct. That cancels out. and this gives you negative a half x squared plus 1.5 is 3 over 2x. So this is basically your equation. Now to find the maximum value, it's the x value, for which x value is KL a maximum. To work out P here is the x value for which it's a maximum. So it's the axis of symmetry of that equation. So here we can say the axis of symmetry, x is equal to minus b over 2a. Remember, if this is your parabola, to work out the maximum value, we first got to work out the axis of symmetry, the x value, which will give you the y value, which is the maximum value in this case. Because the a value is negative, it's a maximum. So the b value here is minus 3 over 2 times negative a half, which is equal to negative 3 over 2 over negative 1. So it gives you 3 over 2. So the p value is 3 over 2 and 0. Why is it 3 over 2? Because for this x value to be a maximum, then this x value, the maximum length of KL will be a maximum if x is equal to 3 over 2, and that will be your p value, the same x value. And because p lies on the x-axis, your y coordinate is 0, so p's coordinates is 3 over 2, 0. Now your last graph, use your graph to write down the values of x for which gx is greater than fx. They're asking, where's the g graph higher than the f graph? The straight line there is higher. The straight line there is higher than the parabola. So for which x values? X less than 3 over 2, x less than 3 over 2, and for which x values here? For the g graph here is higher than the f graph for x greater than 3, for x greater than 3. Where is gx greater than fx? Where is the g graph higher than the f graph? The g graph here is higher than the f graph for x less than 3 over 2, and the g graph is higher than the f graph for x greater than 3. So the x greater than 3, thank you, for x greater than 3. And that brings us to the end of the session of grade 11 functions.